So now we're about to understand what prime numbers are. This is something that I previously discussed with you in your previous class when I was teaching you mathematics in class 5. Now once again, to refresh your mind, it's very difficult to identify and get all your prime numbers because you must know your prime numbers at least between 1 and 100. Now 1 is not a prime number as I've told you because 1 has only one factor, and that is the number itself. To be a prime number, you must have only and only two factors. That means the number should be divisible by 1 and the number should be divisible by itself. Now we all know our prime numbers till 20. So we have 2 which is divisible by 2 and 1, no other number. Then we have 3, 5, 7, 11, 13, 17 and 19. Now what if I told you all you need to know is your prime numbers till 50 and you will be able to figure out from that all your prime numbers till 100. You don't have to know till 100, you must know till 50. Halfway through and your work is solved. That means if you know till 50, I will tell you a breakthrough method as to how to know all till 100. Let's find out the factors till 50. So till 19, I know 19 is a prime number. Now we are finding all the prime numbers till 50. So what again I am repeating to you is, if you know your prime numbers till 50, you know your prime numbers till 100. Is 20 divisible? You have to keep on asking yourself, is 20 divisible by any other number than 20 and 1? Yes, it is divisible by 10 and 2, so it's not a prime number. 21, is it divisible by any other number than 21 and 1? Yes, it is divisible by 3, so not a prime number. 22 is divisible by 11, not a prime number. Then I come to 23. 23 happens to be a prime number because it is only divisible by 23 and the number itself. So 23 is a prime number. 24, no, 3 8s are 24. 25, no, 5 5s are 25. 26, no, divisible by 2. Actually, if you look into it, I can cancel very fast by cutting out all the even numbers because all the even numbers will be divisible by 2. And therefore they will have more than 2 factors. So I can cut out 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 47, sorry not 47, 46, 48 and 50. My work gets done faster. Now I ask myself, is 27 a prime number? Is 27 a prime number? No, it's not a prime number because it is divisible by 3 and is divisible by 9. 3 9 is 27, 9 3 is 27. 29 is a prime number? Yes, it is a prime number because it is only and only divisible by 29 and number 1. 31, is it a prime number? Yes, it is a prime number because it's not divisible by any other number than 31. 33 is divisible by 11. 11 3s are 33. 35 is divisible by 5. 5 7s are 35. 37, is 37 a prime number? Yes, 37 is a prime number because it is divisible by only 37 and the number 1. 39. 3 1s are 3, 3 3s are 9. It's divisible by 3, so it's not a prime number. Come here, 41. Is 41 divisible by any other number than 41 and 1 itself? No. It's only divisible by 41 and 1. It's divisible by itself and number 1, so it makes it a prime number. It's not divisible by any other number. Remember children, again I am emphasizing prime numbers are numbers that have only 2 factors. That is the number itself and number 1. That means it is divisible by its own number, that is the number itself, or it is divisible by 1 and no other number can divide it. But if a number comes in some other numbers tables, you know all your tables till 10, then that's not a prime number because then it's divisible by that number. 43. Is 43 a prime number? Yes, again it is only divisible divisible by 1 and itself. 45. 45 comes in 5 times table. 5 times of 45. So it's not a prime number. Come to 47. Is 47 a prime number? Yes. Because it does not come in any tables of 1 to 10. You don't get 47 anyway. So it's only divisible by the number itself and number 1. And the last we have 49. 49 comes in any tables? Yes, it comes in 7 times table. 7 sevens are 49. So this cannot also be a prime number. Eventually I come to know that from 20 till 50 I have 1, 2, 3, 4, 5, 6, 7 prime numbers. Between 20 and 50. Only 7 prime numbers. Now these prime numbers I am already confident about. I know that these are the numbers between 1 and 20 that are either divisible by the number itself or by number 1, which makes them prime numbers. Now how do I know everything till 100? We've got all this. Now let's write the 20s in 1. So I have 23 and I have 29. In the next column I will write the 30s. So I have 31 and 37. In the next column I will write the 40s. 41, 43 and 47. Once you've made these columns, your work is solved. Now you can find all the prime factors right up to 100. Now how can I find all my prime numbers? Sorry to say factors. How do I find all my prime numbers till 100 after knowing my prime numbers till 50? Because once you know in 20s there's only 23 and 29. In 30s there's only 31 and 37. And in 40s there's 41, 43 and 47 that are prime numbers. That means they have only 2 factors. The number itself and number 1. If you know 23 and 29, then the same thing goes for 53 and 59. 50s also has only 2 factors, just like 20s. 23 and 29, 53 and 59. And the 80s also has the same number of factors, 83 and 89. So if you know your 20s factors, your 20s prime numbers, then in 20s there are only 2 prime numbers, 23 and 29. In 50s there's 53 and 59. In 80s there's 83 and 89. So once I know that my prime numbers in all the 20s is 23 and 29, the same thing goes for the 50s, the same thing goes for the 80s. So in 50s I have only 53 and 59. In 80s I have only 83 and 89. So I know my 20s, I will know my 50s and I will know my 80s. So in 20s the 2 prime numbers are 23 and 29, in 50s 53 and 59, in 80s 83 and 89. The similar thing goes for 30s. In the 30s the only prime numbers are 31 and 37. The same thing goes for the 60s. In 60s I have 61 and 67. So if you know your 30s, 31 and 37, in 60s you have 61 and 67. Now I come to what is left. I've got the 20s, I've got the 30s, the 40s, the 50s, the 80s. What's missing? Let's talk about 90s later on, because 90s has only 1 prime number. That is why I've drawn this circle to put that prime number out there. So we are left with the 70s. 70s matches the 40s, 71, 73, 71, 73 and 79. Now here you will have to be a little careful because 40s and 70s has one difference. In the 40s you have 47 and in the 70s you have 79. You cannot have 77 because 77 is divisible by 11. And you cannot have 49 because 49 is divisible by 7. 7 sevens are 49. So the only unique combination is the 40s and the 70s. They have the first 2 numbers common, but the last 2 numbers are uncommon. 40s has 47 and 70s has 79. But these particular columns are identical. 23 and 29, 53 and 59, 83 and 89, 30 and 37, 61 and 67. And the 40s have the first two numbers common, but the last two numbers are uncommon. One is 47 and the other is 79. Why? Because 49 cannot be there, because 49 is divisible by 7. And 77 cannot be there, because 77 is divisible by 11. So these are the only uncommon ones, but the combination falls this way. Which number are we left with? 90s. The 90s has only one prime number, and that is number 97. The 90s doesn't have any other prime number than 97. So this is how you can enlist all your prime numbers. Now this entire thing has to be written in your notebook, as I have done it. Write it with pen. What you see circled in pink has to be done with pencil. You will circle with pencil, cancel with pencil. Circle with pencil, cancel with pencil. All these numbers that you are seeing, everything has to be written in pen. What you see in pink has to be written in pencil. Once again, what you see in white has to be written in your notebook with a black pen. And what you see written in pink, that is the cancels and the circles, they have to be made with a pencil. This will come immediately after my instruction in the next video.